All right, so the beginning part of chapter 6 is on vectors. So obviously we need a little bit Despicable Me here.
I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term, a quantity represented by R with both direction and magnitude.
Okay, so that is what a vector is, something that has both direction and magnitude. So let's write that. A vector is a quantity that involves both what and what? Yeah. Okay, so some examples of vectors. You don't have to write the examples if you don't want, but physics people, can you give me some examples of vectors? So like velocity would be a vector because velocity gives you speed and direction, okay? So like I'm going 60 miles per hour to the right if your velocity is positive. Acceleration is a vector. Force. Okay. Some scalars would be distance, speed. So scalars are just numbers. They have no direction attached to them, okay? So we are going to be looking at vectors today. So just make sure you've got that definition in your notes. A vector is a quantity that involves both direction and magnitude, okay? You don't need to write anything yet, but we use directed line segments to represent vectors, okay? So look at all the vectors I have. See how we've got line segments with arrows on them, so they have a direction to them. I can move all of these. Let's see if it'll let me. If I move them all to the origin, do you see how they become exactly the same vector? Right, so they all have the same what's called component form, okay? So now take a look at the blue vector that's left. You see if I were to move it to start at the origin, where would it terminate? Where would it end? What point? 6, 6, right? Now, if I move that back, how would I get from 2, 4, and 8, 10 to 6, 6? You see it there? So we're just subtracting, right? Okay, so let's write that. To the component form, your vectors look like this. You've got your angled brackets. So the component form of all of those vectors was 6, 6. In other words, your component form is where is my terminal point when I move my initial point to the origin, okay? If your initial point is not the origin, how do we go from the blue to the black? Subtract. Doesn't matter what order I subtract. Subtraction order matters, right? So terminal minus initial or initial minus terminal? Yeah, where you stop minus where you start, okay? You may also see this in linear combination form. We'll talk more about this in the video tonight. You may see I's and J's, so when you're writing them, if you draw a little arrow above the I, that means it's a vector. Same with J. In printed form, you just bold those. Just write that notation for now so that you know they're the same. We'll talk more about why that notation works. All right. Now, we also need the magnitude. Okay, so magnitude is how long that vector is. Well, how would I find the length of this black directed line segment? Yeah, absolutely. Think about it. I've gone to the right 6 and up 6, right? So distance formula tells me I would do square root of 6 squared plus 6 squared. So square root of 36 plus 36, square root of 72. Okay, so just kind of some basics of vectors. All right, so we're going to start out with some basic operations today. If I multiply a vector by a scalar, and what's a scalar again? Just a number. So let's say I have a constant c, and I want to multiply it by the vector a comma b. And again, that means that if it's in that form, I start at the origin, and I end my vector at the point a comma b. Well, not surprisingly, what do you think the answer is? Yeah. Just multiply both a and b by c. If I want to add two vectors, let's say ab plus xy, how do you think we do that? Add the x components, add the y components, right? Not a big deal. I've got an example of scalar multiplication, what happens graphically. So not surprisingly, if I take a vector v and multiply it by 2, what do you think is going to happen? I can stretch by a factor of 2, right? If I multiply it by 1/2, it's going to shrink. What do you think happens when I multiply it by a -1? Flips, right? Yeah. If I originally had the vector like 2, 2, that would be -2, -2. So it just flips over the origin. Okay, let's try a couple examples. Can you go ahead and write down vector v. So it's 2i minus 6j. In other words, I'm going to start at the origin and end my vector at the point 2, -6, like I have here. So again, this is another way to write 2, -6 in component form like that. So what would 2 times v be? Yeah, so what would my answer be? Right? If I were to plot that for -12, see how I just lengthened it by a factor of 2, right? And then -2v will be -4 comma positive 12. So it'll be twice the length of my original, but in the opposite direction. Yeah. Yes, you can totally still write this as same thing. Again, I'll tell you more what I and J are in the video, but I want you to get just kind of familiar with seeing both. And in my math lab, just make sure you read the little blue text, right, to see how they want it written. Component form here, or linear combination form here. Okay, let's try some addition now. Okay, can you write u and v in your notes, please? So u is 1, 4 in component form, v is 5, -2, and I've graphed both. You don't need to graph them in your notes, but I just want you to kind of get that visual as well. So what do we get for u plus v? 6, 2. Absolutely. Now watch what happens when I do what's called tip to tail method. So if I attach tip to tail, be about there, right? And then if I draw my new vector at the origin, can you see where I land? 6, 2, right? So graphically, it's called tip-to-tail method. Algebraically, it's not anything earth-shattering, right? We're adding our components to one another. And we can subtract as well, okay? So if I subtract these two, if I do u minus v, again, order matters here, what would I get? Negative 4 comma 6, okay? So what's happening graphically, if, let's see, this was v. So if I flipped that, it would be negative 5, 2. And then if I do tip to tail with those, you can see I would end at negative 4 comma 6. Yeah. All of them start at the origin. So if you see your angled brackets, you're going to start at the origin and end at that point, right? So if I were to just give you negative 4 comma 6, that's an ordered pair, right? It's just a dot. But if those same values are in angled brackets, that's a vector, meaning it starts at the origin, ends at that point. Meaning your arrow should be on this point. Does that make sense? The notation? Okay. Yeah, nothing too, I think, surprising here yet. So remind me, what does unit mean in mathematics? Where have we seen that word before in this class? What's that? Measurements. Okay. I would say that's more the science term. You're right, though. Where we've seen unit before in pre-calc. A lot of it. The unit circle, right? The unit circle is a circle with radius 1, okay? So unit in mathematics means 1. So can you write this definition, please? A unit vector is a vector with length, what? 1. Unit in math means 1. Oh, really, it means the multiplicative identity. But for the real numbers, that would be 1. We denote the length of a vector with kind of this double absolute value sign. So the length of vector v, the notation is that, okay, or also known as the magnitude, right? So if you see these double absolute value bars, that means the length. Okay, so here's let's say that I have a vector, what does this mean? With length magnitude 5, exactly. And let's say I want to create a vector in the same direction as v, but with length or magnitude 1. So it originally has length 5. How do you think I would shrink it down to have a length of 1? Multiply by 1/5, right? Or divide by 5, however you want to see it. Same thing, correct? Now, if it has a length of 1, what is it called? A unit vector, okay? So let's try an example. It says find a unit vector. What does that mean again? Length of 1, great. In the direction of v. So we are going to, our strategy will be to find the magnitude. And then take v and divide by that number, which is what you just told me. So divide by 5 or multiply by 1/5, either way. So our example says find a unit vector in the direction of v, then verify it does have a length of 1. Okay, so first we need to find what? The length. We need to find out how long is the original, right? And then shrink it down by that factor. So how would I find the magnitude of v? Let me go back a few slides. How did we find the magnitude? distance formula, right? Square root of the x component squared plus the y component squared. Okay, so here, the x component squared is 9 plus the y component squared is, so the answer is square root of 25, which is 5. Okay, so my original length is 5. So how do I take v and shrink it down to have a length of 1, make it a unit vector? Divide everything by 5, right? So the unit vector is going to be what? 3 over 5, comma. Absolutely, that's all. That's your answer, okay? And I could verify, if I now take the magnitude of this, I'd get square root of 9 over 25 plus 16 over 25, which is 25 over 25, which is 1. Okay, so let's do a little bit of a summary. If you see angle brackets, again, you do not need to write this down unless you want, whatever is helpful in this for you. So if you see angle brackets or linear combination form, that means we have a what? Vector starting where? Yep. And ending, yeah. And put at that point, right? Whatever we have there, okay? Okay, what if I want to find the component form of a vector that starts at AB and terminates or ends at CD? What do I do? What operation? Subtract. Start minus end or end minus start? Okay, so what would I have? C minus A. Okay, so terminal minus initials, end minus start. And how do I find the magnitude? Good. Distance formula. You good with that? Okay. You try one. And if you are watching, go ahead and pause, hit play when you're ready to see answers. All right, so for component form, make sure you do end minus start. So what did we get? 6, negative 10. Love it. If I asked for it in linear combination form, it would be 6i minus 10j, right? But I did not ask for that. Okay. How do I find the magnitude? What does magnitude mean? The distance, the length, exactly. How do we do that? Great. So the x component squared is, yeah, because remember you're starting now at the origin, so you're technically doing 6 minus 0 squared plus negative 10 minus 0. So the y component squared is, one way is square root of 136. Do you agree with that? Remember, for my test, you never have to reduce or simplify. Okay, what if I want a unit vector? What does unit mean? 1. So what do we do? Divide, exactly. So again, maybe not simplified the most, but one option would be this. Does that make sense? Awesome. Okay, so you should be good to start MyMathLab. The homework packet should be on there for you, but just a little bit of note. In MyMathLab, radicals are okay in the denominator, but be sure you simplify radicals and reduce fractions, okay? So what I mean by that is rationalize when you can. Does that make sense? So don't put square root of 8, put 2 square roots of 2. MyMathLab considers those as inequality symbols. So again, be very careful with your input once we get started here. If you're having issues with that, let me know.